In this video, we will discuss the algebraic properties of vectors in Rn. Just like any operations, vector addition and scalar multiplication has properties that are very useful when we solve series of vector operations. Suppose we have vectors u, v, and w, and these vectors have n components. These vectors can be any vector that you can imagine for as long as its components are real numbers. Suppose further that we have scalars c and d, which are also real numbers. Then, the first property tells us that the sum of vectors u and v is equal to the sum of v and u. We call this as commutative property of vector addition. The second property tells us the associative property of vector addition. That is, if we get the sums of vectors u and v, and then add it to vector w, then it is equal to adding vectors u to the sum of vectors v and w. The third property tells us that if we add vector u to a zero vector, we get the same vector. The fourth one tells us that if we add vector u to itself, but multiplied by -1, then we get the zero vector. The fifth property tells us that we get the sum of vectors u and v, then multiply it to scalar c. It is equal to the sum of c times vector u and c times vector v. The sixth property tells us that if we get the sum of two scalars c and d, then multiply that sum to vector u, that is just equal to the sum of c times vector u and d times vector u. The seventh property tells us that if we multiply c and the product of d and vector u, it is equal to the product of the two scalars times vector u. Finally, if we multiply 1 to vector u, then the result is itself. Let's try to illustrate the first property by giving example and by proving the statement. Suppose we have two vectors, vector u, which is equal to 1, 3, and 2, and vector v, which is -2, 1, and 5. If we perform u plus v, then the result is -1, 4, and 7. Now, let's try to prove this statement. Suppose we have a vector u with n components. The components of this vector are u1, u sub 2, all the way down to u sub n. Let's also have another vector, vector v, with n components, and these are v1, v sub 2, all the way down to v sub n. Our objective is to reach a v plus u argument from u plus v argument using all the things we know in algebra. So, we start from u plus v statement. We know that vector u is equal to this vector and vector v is equal to this vector. Therefore, I can replace these vector names to its equivalent column vector. Combining these two vectors, we get the new vector, which is the sum of the corresponding components of vectors u and v. Remember that in algebra, addition is commutative. Therefore, I can interchange the position of the components. Next, I unmerge these two vectors based on the definition of vector addition. Finally, these vectors are equal to vector v and u respectively, which proves our case. You may also want to try proving the other properties using this strategy. Thank you very much for watching and have a great day.